right? The last slide, again, is just a feeling. You understand the situation that you still want to keep the small AC gain, you need such a big device. Okay, so what is output stage? Source follower output stage. Now it has a large swing, right? It's pretty complicated. We cannot use this equation anymore because it's not small signal. So, but let's look at the structure first. You recognize that this is still a source follower, except that, and not except, we just bias it with an ideal current source. Like here, this is not ideal, but this is a current source, right? You can come from a current mirror, correct? No, current mirror, again, another hint, we study current mirror, right? So you may bias this to something like this. You have a golden current source, right? Do you remember how to bias it? Right? Instead of really putting a battery with VB, we actually let this current mirror to bias this one, right? And do you remember if this is I, what is the current here? How do you find the current? Do you remember? Sorry? The ratio of the W on L. Yeah. So this is, just remember, for example, if M2 is double of this one, this becomes 2I, right? If M2 is half of this one, then this becomes I over 2. Okay? Now, if this is I over 2, what if this one is 3 times of the bottom one? M1 is 3 times of M2. What will be the current in M1? If this is, let's say if this is I, let me call this I2. If this is I2, and the area W on L of M1 is 2 times of M2, what is the current in M1? Who think that it is, so I'm saying that the area is double of this one, right? So who think that this is 2I2? Raise your hand. Who think this is half I2? Who think that this is I2? Assume they are?
Assume they are connected to something.
No. Look, we're just talking about DC bias. Huh? Should be I2. You know, if you did not learn about current mirror before, everyone would say I2. Because this one gives you another equation and you use it wrongly. This is just KCL, right? So if this is I2, what should be M1? It must be I2, no matter what area you have. But you get confused because now we're talking about the copying the current from here to here, right? This one has nothing to do with area. So if this has a unit of 1, this has a unit of 2, then the current will be double. But once you double to here, all this current will flow through M1, right? Do you agree? Just KCL, right? You really need to remember why we can have double, because again, we derive the equation and find that they depends on the area because they have the same gate voltage. That's why it depends on area. But here is different. This is just KCL. Okay, so this is a hint. Don't make mistake, right? Be very careful. Okay, so then naturally, if I have current here, all the current will go out, right? Really doesn't matter what area I have, just like what we said earlier. So with that, and then we are going to load this guy here, 8 ohm. Okay, that may be a speaker, which is RL. And our input is here. And this is V out. Now, if you just look at this figure, and if I did not tell you this is large signal analysis, then this looks like just a source follower. You just use the equation, and which is correct. It's still correct. You just assume small signal, you get source follower. But now in this case, we actually want to apply a large swing, maybe from -1 volt to 4 volts. That is a big swing. In that case, we cannot linearize the circuit anymore. We really need to solve the KCL, KVL, and use the transistor equation, which is pretty lengthy, okay? But we are going to do an assumption. We assume the VGS is almost equal to VTH, meaning that there's almost no overdrive. So what does it mean? Then it means that the W, we have a large W on L. Why? Because the current I, right, I should call this I0, is, if I call this IM, the transistor current, equal to, I just call it is only IM. I cannot say it's equal to I0 now. W on L, mu C ox divided by 2, VGS minus VT squared. If I have a large W on L, VGS minus VTH is small, right? For a given current. For given IM, large W on L, give me small VGS minus VT, right? I only need to overdrive a little bit. So as a result, I can say VGS minus VT equals to 0. Just approximation, completely approximation, because to solve it is very tedious. You need to use LT spice or something, right? But here, we just approximate. What is VGS? Can you tell me based on the notation there? What is VGS in this case? Thank you. V in minus V out. This is very important. That means V out is always equal to V in minus VT. Is this okay? And that makes sense, right? We are talking about source follower, right? So V out needs to be always something below V in. Okay? Just like what we discussed before. It's still large, but now it is large signal. Is this valid? Not exactly, but pretty close. As long as we have a large W on L. As long as the biasing condition is still making it at the saturation. Okay? Just like in your transistor, in your lab, right? So you can check this if it doesn't work. So let's look at a few scenarios. The first scenario is this. What if the V in equals to 4 volts? What should be the V out in this case? I say VTH equal to 0.4. Yeah, very good. So it is 4 minus 0.4 equal to 3.6 volt. Say okay? Okay, so 0.4 here. So V in now is 4 volts and V out is 3.6 volt. My question to you. And then I forgot to say that we assume the current is 0.1 ampere. Okay, because I set it up, it's my choice. What is the current going through the resistor in this case? Yeah, but just very simple Ohm's law. What's the current? You have a current going down, right? What is that? 3.6 minus 0 divided by 8, right? You will feel that why you minus 0? Because that helped me to find a mistake. I'm sorry, I make a mistake again here. This is not grounded. Okay, please change it. This is negative 5 volt. Okay, I have a rail that is not grounded. Okay, I forgot to. Is that okay? This is 5 volt. Negative 5 volt, not 5 volt. Negative 5 volt. Okay. So the current is 3.6 minus 0, right? So what is that? Equals to 0. What is that? 5? No, 0.4. 45, sorry. (0.45 ampere. Is this okay? Then what is the current going through the transistor? IM equals to IR plus I out, I0, not I out, I0, equals to 0.45 plus 0.1 equal to 0.55 ampere. Everything normal? Make sense? So when the input is 4 volts, output is 3.6 volt, all the current going from 5 volts, some of them go to the current source, some goes to the resistor to drive the load. No problem, right? So this one is okay. Then let's move a little bit faster. What if V in equal to 0? What should be the V out? Source follower. Now you start getting nervous. Well, is 0, is it still on or off? So we need to make some assumption. Let's assume it is still working. So what should be the V out? What should be the V out? Negative 0.4 volt. And if you are not comfortable then, but now I show you that my rail, bottom rail is negative 5. So it's possible, right? I'm not violating any physics, okay? So if that is the case, what is IR? IR is pointing down. So how do you calculate IR? Negative 0.4 minus 0 divided by 8, which is equal to negative 0.05 ampere. What is the meaning that I have a negative current going down? It means it's going up, which makes sense because now I'm saying that this is 0 volt, and this becomes negative 0.4 volt. So you have 0, and here is 0.4. Then of course the current will go up, right? So don't get confused, right? It is normal. Everything works well. Nothing's wrong. So the current goes up. But now what is IM? Well, you can continue to use the KCL. Just be careful of the direction. I still think that IR is going down. So this is negative 0.05 ampere plus 0.1 ampere, which is 0.05 ampere. It's just saying that, well, because you're supplying current from the resistor to this load, right? I don't need to supply so much here, right? I only need to supply 0.02. So IM is pretty small now, but it is still on. Make sense? Right? So the concept is that I start with high voltage, then the IM, the transistor is giving current to the load and also to the current source. But when the voltage goes down, at a point, the current will flow from the resistor to the load, which is okay, right? Because it's just AC. We are doing large signal. You are still supplying and current and drawing current from the resistor, right?
So given the equation, we can calculate roughly which the transistor stops.
Okay, and that is the equation you need to memorize if you want to do well in your midterm. Now, when V in equals to negative 0.4 volt, what is V out? Yeah, we need to assume that it works, right? So can you see the color? Maybe no, but I cannot find a better one. Or we can use the dark one. Negative 0.8 volt, right? Do you agree? I'm assuming that it's working, okay? Then what is the IR? I want you to tell me how to calculate. IR. Again, IR is pointing down, right? IR is here. So how do you calculate IR? By Ohm's law? No. minus 0.8, minus 0. I hope you to follow this, right? Do not make mistake. What is this? Negative 0.1 ampere. So I have 0 coming down, right? So this becomes negative 0.8 volt, negative 0.4 volt. And then now my current is 0.1 going up. And this is drawing 0.1, right? So what is Im? 0. Simply when a transistor has 0 current, it just turned off. Okay? So maybe we can also assume this is correct, is in the transition region. So you see that if I input as a 4 volt, 4 lower volts, it works until it's negative 0.4 volt. Right? And after that, what happened? After that, I don't have the drawing here, but I think you can remember when we, let's call this 4, when we equal to negative 2 volt, right? If it works, then we expect V out equal to what? Negative 2.4 volt. If it works, then it means that IR equal to negative 2.4 divided by minus 0, very good, divided by 8, which is negative 0.3 ampere. It means I have negative 0.3 ampere going up, right? But then, as you can see here, this is only drawing 0.1. Then the others need to go up, right? Otherwise, you violate the KCL. Then basically, you see that MIM equal to negative 0.3 M plus 0.1 M equals to negative 0.2 M. Basically, you're saying that under this situation, I have a current equals to 0.2 going up. Is this possible? No, because in this case, it means that this one has a larger potential than the top, right? Then this becomes what? More than 5 volts. How can you get a node inside your circuit to be higher than the maximum potential you provide, right? And this is just because we make the wrong assumption that this is still working. It's not working anymore. It's actually still off. That's just what I want to say, right? Now, so with this, then we can start drawing the result. I have the input V in here, and then I have the V out, right? It's in 2 slides, so it's not easy, but it's good if you can memorize what we just discussed, right? We start with 4 volts, output is 3.4, then I keep going down, become negative 4, and then negative 0.4 become negative 0.8. So it's like this. This is 4. It gives me 3.6 output, and then we keep going down. When I reach negative 0.4, this is negative 0.4. When I reach 0, the input is 0, output is negative 0.4. Is that okay? And then I make the input lower, and eventually it just flat out. I need to draw a better one, because it's really flat. And this is the point, negative 0.8, when your input is negative 0.4. Is this okay? You just keep going down. You shift it. It's just like, ideally a source follower, you want it to be x equal to y. But this is shifted because of the VTH. But it still works until it reaches negative 0.4, right? So basically, you have this free region. This is 1, right? And then where your input equal 2, and then 3. Right? And eventually, this is maybe 4, which is impossible. You don't get this, so it's keep getting off. Right? It is off, and then you just keep at that stage. So this now very important tips, right? So what is the lowest V out you can get? The lowest V out you can get is when I0 equals to negative IR. Okay? It is when IM just turned off, like here. I0 equals to negative IR because they sum to be 0, right? This is very important equation. I think I'm too nice giving you hint. Right? So what is that? It is I0 equals to negative V out minus 0 divided by RL. Because V out minus 0 divided by RL is IR, right? So the V out minimum equals to, maybe I should call this minimum, equals to negative I0RL. Okay, so if you have a power output stage, that is what you will get. You can have the follower keep going down, but then you got stuck at negative I0RL. And in this particular case, it is equals to negative 0.1 times 8, right? Because RL is 8, I0 is 0.1, so it's negative 0.1 times 8, so you get negative 0.8 volts. That is what we get here. See, this is a drawing problem. Right, so let me just be very clear. This point, right, negative 0.8 volts. Any questions? Understand now, right? Instead of after the midterm. Any questions?
So this is why when we don't connect the load to the output of the source follower.
No, this is
we can get into the range as long as there's power supplies there.
This is a limitation of using source follower as the load. Yeah.
Okay.
So let's see what the limitation, let's understand a little bit better. So I just drawn this curve to you. I have V in, V out, and I just say that it goes down, the slope equals to 1, right? And it will keep going down and then flat out, right? And this is negative 0.4. And this is negative 0.8. Yeah, is this okay? What happens if I have a small signal coming in? T, voltage. Right, I assume this is a small swing. I don't call it small signal, sorry. It should be small swing. It's still large signal. I have this signal coming in. So what is the output? This is V in. What will the output look like? Well, I will just say this, and then the shift is how much? 0.4 volt. Because whatever you come here, right? Maybe I just remove this low. I don't think you can, it's going to confuse you when you study. Because all of them shift by 0.4, right? Because this is x equal to y. Let me just be clear. Maybe I should not do that because my drawing was bad. Then make it even worse. So what I'm trying to say is this. This 9 is x equal to y. V in equal to V out, right? Now I shift everything down by 0.4. Maybe I should try actually. Let me still try. So this one 0.4. Okay? And that's why the whole thing shifts down by 0.4, right? Because your input is this, then you come here, and then your output is shift down by 0.4, right? This is x equal to y. V in equal to V out. Okay, that is okay. Then what if I have a large signal? And that will cause some problem. So let's say I have a large signal, and this time I need to give some numbers. So let's say I have this. Okay, so this is pretty large. And let's say this is 0.8 volt. And it goes all the way to, let's say, this is negative 0.4 volt. Okay, so I have a large swing, right? It is allowed, right? Because I bias from 5 volts to negative 5 volts. I try to swing from 0.8 volt to negative 0.4 volt. Actually, no, actually 0.4 is not going to give distortion. I'm sorry. Let me redo it.
They'll be distorted slightly just because the gain of the amplifier is slightly nonlinear.
Yeah, but we cannot see this in our model, right?
Yeah.
So, so let me just do it again, a larger distortion like this. Okay, and then I'm saying that this is the pen, right? This is 0.8 volt. This is negative 0.8 volt. Okay, so if nothing happened, if I have an ideal source follower, how would you expect this to happen? What would be the V out? This is V in, right? What would be the V out?
The peak would be 0.4, and the bottom would be negative 1.2.
Okay, so you just shift everything by 0.4, right? If nothing happened. So it will be something like this. Right? So this is ideal V out. So this one will be 0.4, and this one will be negative 1.2 volt. Is this okay? But in reality, let's trace it. Okay, when you say you have 0, I look at this. 0, input is 0, output is negative 0.4, which is okay. And then I just keep tracing. But then eventually when I reach here, when I reach 0.8, when your input is negative, when your input is negative 0.4, it will give me 0.8, right? When this input is negative 0.4, negative 0.4, it gives me negative 0.8, which is okay. But then now the input is lower than the 0.4 in this region. In this region is negative 0.5, negative 0.6, negative 0.7, negative 0.8, right? What's the output? It's always negative 0.8. So as a result, from here, I will just give a constant output at negative 0.8. And then when you go up again, okay, I can trace it. Right? So this is the real V out. And this is the distortion. Okay? Any questions? Maybe I need to be slow, but this is important, right? As I told you, make sure that you understand everything. Any questions? So you see the limitation of this is, probably we don't have time for simulation, but that is okay. You see the limitation of the source